The trapping rainwater problem, which is LeetCode question number 42, is one of the harder problems to solve on LeetCode. But if you use the two pointers method to tackle this problem, it will become much easier. In this video, we're going to take a look at how to solve this problem using the two pointers method. Let's first take a look at the question itself. Given n non-negative integers representing an elevation map where the width of the bar is 1, compute how much water it can trap after raining. Example 1. So we're given this heights array, which is these numbers. So each one, for example, 0 is 0's elevation. The 1 represents the 1 elevation, this dark here. 0, it becomes 0 again. And then this blue part is where the water is trapped. So this part is trapped 1 unit of water right here. And then we go to 2. There are 2 black blocks here. So this is the next elevation. And the next elevation is 1. So on top, there's 1 unit of water trapped here. The next one is 0. So there are 2 units of water trapped here, etc. So in total, we have, if you count all of these blue parts, we have 6 units of water trapped here. So when a heights array is given like this, the output will be 6. So that is the entire idea. So how do we use the two pointers method to solve this problem? Now let's take a look at the solution of this problem. Let's start from the definition trap, and we're given the heights array. So the first thing that we're going to do is we're going to initialize our left and right pointers. Our left pointer is first going to point to the 0th index on the left side, and then the right pointer is going to point to the last index, which is the length of the entire array minus 1. So these are the left and right pointers. The next thing we're going to do is we're going to initialize 2 more variables, left maximum value and right maximum value. The left maximum value first is initialized to the leftmost value, which is just h left, and then rightmost value, or the right maximum value, is going to be first initialized just to the rightmost value, which is h right. The next thing that we're going to initialize is the water variable, which is the accumulation variable, and we're going to report this trapped water at the very end. First, we're going to initialize it just to 0. So after initializing all of these variables, we're going to loop through or scan through the entire array using our left and right pointers. To do that, we're going to use the while loop. While left pointer is less than the right pointer, this is our condition, and we're going to meet at some point in the middle. While this is true, we're going to first take a look at or compare the left maximum value and the right maximum value. If left maximum value is less than the right maximum value, we're going to move the left side, because the left side is here. If the smaller side is going to decide or limit how much water we can trap. So in this case, if the left maximum is less than the right maximum, we're going to move the left side by 1. So to do that, we're going to do left plus 1. So now that we've moved the left side, we're going to focus only on the left side now. Because we've moved the left side, we're going to update our current position with the previous position. So you can think this line as we're comparing our current position, which is the h left current position, and then the LM, which is the leftmost bar, which is the boundary. This is going to be the left boundary. We're comparing the left boundary that we've set before, which is just the h left previously, and our current position, which is h left. Whichever one is the higher, we're going to take that one and then update the leftmost value with it. So after updating the leftmost value with it, we're going to calculate how much water we actually trapped on the left side. The water trapped is going to be equal to the left boundary that we have so far minus our current position. Our current position here is after moving to the left by 1. So LM minus h left. So if our current position is less than previously, we actually are trapping some water. If this current position actually equal to this left boundary or more than this left boundary, we are actually not trapping this any water, so it's going to be 0. In order to trap water, this current position that h left we're in right now is has to be lower than this left boundary. What if the left maximum value is actually bigger than the right maximum value? In that case, we're going to move the right side to the left. We're going to do it by right minus 1. After that, we're going to update the right maximum value using the same logic. Our right maximum value is going to be equal to max function, and then we're going to compare the right maximum boundary and then our current position after moving the right to the left by 1. So after updating this right maximum is updated. We're going to calculate the trapped water. The trapped water is going to equal to right maximum value minus our current position. So after that, this water accumulation is calculated here. And after all of this while loop is done, so we meet at some point, and then we're going to, in the end, return this accumulated water. So that's the entire logic of this problem. Now let's take a look at if this works in LeetCode. Let's paste the solution and run it. So it has been accepted and it ran successfully. So this is how we solve the trapped water problem in LeetCode using the 2 pointers method. Hopefully you learned a lot in this video. In our next video, we're going to continue with other problems. So stay tuned. If you like this content, please subscribe and check out other similar videos.